There are many who claim that science and art don't mix. These people have apparently never read anything by Christopher Cokinos, who masterfully demonstrates the art of science in his very intelligent but personalized writing. He is the author of 2 books and several essays, poems, and reviews, and has won numerous awards and grants. His writing appeals to scientists and artists alike, and even to those who realize that the two aren't mutually exclusive. I first came across his book, The Fallen Sky, An Intimate History of Shooting Stars, as I began my own essay on meteorites. Like Cokinos, I was interested in the facts of meteorites, where they come from, what they're made of, what sort of havoc they've wreaked on Earth, as well as my chances this year of death by meteorite. It's 1 in trillions, in case you were worried. But Cokinos' book is not just a textbook on space rocks. Instead, his passionate curiosity is tangible and infectious. He grasps at the mystery of humanness, with its deep passions, strengths, and flaws. Cokinos writes, "We each have found ourselves lost in the dark wood, whatever we thought the true way had been or can be, but for me, the path out was lit at times with the passage of shooting stars. The next time I look to the sky to catch the fiery rain of the Perseids meteor shower, I might watch for the colors of the meteor's tails to try to figure out their composition, but I will also look on in wonder at the mystery from the heavens and the mystery of my own existence. We are all searching." In Cokinos' words, that chance for discovery keeps one looking, with that hope for the sparkle beneath skin, elation. Please welcome Chris Cokinos.
Thank you. Thanks for coming, and thanks for that lovely introduction. I hope I get to read your essay on meteorites. So I want to thank Cassie for getting things set up, and Patrick for organizing the reading, and my other friends here at BYU. I don't know if George is here, Kim Johnson. Antarctica just vanished, so you got a treat there for a minute. We'll get it up in a second. Anyway, thank you. I thought it was appropriate that there was a picture of snow and rocks up there on a lovely spring day, and I decided deliberately to wear a sort of bright green shirt as a talisman to bring spring back. I don't know about you guys, but it's getting a little tiresome in Cache Valley. So anyway, thanks for being here. I like to give people a little bit of a sense of what I'm doing, so you know where I am at any given point in the talk, and I don't want to overstay my welcome. So I'm going to talk a little bit about dust here in a second, which actually has a lot to do with meteorites. And I'm going to read probably 2 or 3 excerpts from the book, a little bit of the introduction, and then a passage from the middle of the book about a guy named Harvey Nininger who transformed the science of meteorites. And in my studies of him, just gave me a sense. Amy mentioned the sort of humanity or humanness of these characters. And so it's a little bit of a case study in obsession, in passion, its costs, and its pleasures. And then I'll end with a brief excerpt of which was up there, my hunting meteorites in Antarctica. So, I don't know. Cassie, can we get the picture back? Probably just. There we go. Okay. And if it gets really boring, I can just check my email up here, and we can read my email or check the sports pages, since free agency began in the NFL last night, and I'm concerned about who the Chicago Bears are signing or not signing. So, we can do that in the question and answer period too. So my joke has been, I guess it's not that funny, but my line has been, I've written this book about meteorites, and on the cover there's this gigantic meteorite in the middle of Africa, the Hoba Iron. It's, I think, 64 tons. It's so large it's never been moved. It's still stuck in the ground. And what I would say, especially in doing interviews, was it's not really a book about meteorites. It's a book about meteorites, okay? It's really not only about these things, and I'll pass this around, this is an actual meteorite, but it's about the hands that hold these rocks, that are going out and searching for them. And that's why this is an intimate history of shooting stars. It's not just an intellectual connection. It's not just a scientific or textbooky sort of discussion of these things, but it really is an intimate history. It's about the human connection to the cosmos. I'd love to have this back. So this is the oldest thing you'll ever touch. Okay, it's a meteorite from the asteroid belt. It fell in North Africa. I'm not sure when. I can talk a little bit about how I got a hold of it. It's kind of mundane. I ordered it from a meteorite dealer. There are dealers and collectors and hunters of meteorites, some of whom have made quite a fortune. So I bought that meteorite for $80, and it arrived in a box in the mail. So there's no particularly romantic story involved with it, but it is 4.5 billion years old. So it's this thing that plowed through the atmosphere. You know, you can imagine it as far away as the moon, say, 250,000 miles away, going so fast that in 3 hours it traverses that distance, and it hits the atmosphere, and it starts to burn. It ionizes this trail and breaks up, and this bit of stone happens to land in the Sahara Desert in North Africa. And when that happened, I don't know. When that happened, the dealer doesn't know, but eventually it was discovered. There happens to be a big trade in meteorites out of North Africa, and so Bedouins are actually going across the sands of the desert looking for these things, and then they work their way back through Morocco, and there are all sorts of maybe shady things going on. But I mean, that's kind of an amazing journey. And then suddenly it's on my box in my living room in Logan, Utah, and I'm opening up this thing, and here's this meteorite. It's just, I think, kind of strange. So it's 4.5 billion years old. It dates from the origin of the solar system, but it also has, a human story attached to it. And this stuff is plowing into the atmosphere all the time. If we had perfect conditions over the planet for 24 hours, let's imagine it's dark throughout the skies, both sides of the planet. The weather's clear, there are no clouds. We all had really good eyesight. You would see probably 24 to 25 million meteors in 24 hours. So the sky is trellised with this stuff, and we just don't see it all the time. We see it in the summer when the Perseids are firing, or when the fireball flew over Salt Lake, Valley a couple months ago. When was that? I can't even remember. I got interviewed by KSL. They came up to Utah State and said, "So where were you when that fireball passed?" It's like, well, I was asleep. I was in bed, so I didn't see it. I saw the video, but so this stuff is falling all the time. And in fact, if you get hooked on the idea of hunting meteorites, you should know that every square mile of the planet gets about 8 meteorites, new meteorites, per year. So just off campus somewhere. Now, they're usually not very big, okay? They're probably like this big, all right? But they're happening, it's happening all the time, and this stuff is plowing into the atmosphere. There are different estimates, 100 to 1,000 tons of dust and rocks plowing into the atmosphere every day, okay? And both the amateur meteorite community and the scientific community is really interested in this stuff. And so like the one I'm passing around, that could have hit the atmosphere at about 44 miles per second. Or if it was much smaller, like, say, a piece of dust, it might have just sifted down, okay? Just sort of floated into the air and eventually worked its way to the surface of the planet, even to the bottom of the ocean, okay? So we have a wide scale of things. I think we're all, how many of you have seen Deep Impact, or Armageddon? Okay, so really big ones will hit sometimes, and mostly it's really small stuff. So I want you to just kind of hold that in mind, this wide scale of cosmic stuff that's hitting the atmosphere. Really big rocks, big enough to cause mass extinctions. Rocks like the Perseids, which are very small, okay, like the size of a bird's eye, maybe, would cause a really bright fireball, okay, burn up. The Perseids never reach the surface of the planet for a variety of reasons. And then there's dust. And dust is sort of where I'm going to start. If you've had a sandwich today with lettuce, or you are going to have a salad after the reading, you'll probably actually eat some cosmic dust. It's that ubiquitous, okay? When you're dusting your house, some of that dust came from outer space. So it is around us all the time. And that was another reason why, as I was working on the book, I realized this is not just a book about science, because what we think of as out there is right here. It's with us all the time. And dust, it turns out, played a really crucial role in the formation of the solar system. This is the most sciencey part of the reading that I'll give you. So dust is kind of like an ancestor, all right? Without dust, the formation of the planets would not have taken place. Meteorites wouldn't be here. We wouldn't be here, okay? So this really, the stuff that we clean up is actually important to the evolution of the solar system. But dust gets a bad rap. It's an adjective for products whose nouns are mop, remover, or buster. In Queen's song, so catchy it can be impossible to forget, another one bites the dust. The rock group Kansas whimpered that all we are is dust in the wind. The slow shall be left in the dust. The feckless shall eat my dust. History, when forgotten, dies in a dustbin. Dust to dust, we're told. Emphasis on the dry conclusion. The dictionary offers this disagreeable definition of dust. 1, powdery earth or other matter in bits fine enough to be easily suspended in air. 2, a cloud of such matter. 3, confusion, turmoil. 4, earth, especially as the place of burial. Mortal remains disintegrated or thought of as disintegrating to earth or dust. 5, a humble or abject condition. 6, anything worthless. I think it's, that's some serious disrespect for dust. When I lived in Kansas, nearly every morning I'd wet old rags, then tie them to a broom. I'd push, turn, and drag the jury-rigged mop across oak floors, retrieving especially egregious aggregations from beneath the bed. Then I would step to the front stoop, lift the yellow dust mop to the sky as if it were a banner in my war on entropy, and shake it like mad. Hair, grit, mites, skin, floss, lint, insect bits, pollen, seeds, poof, all manner of heinous detritus. With cheer, I launched them all. The cloud usually traveled east toward a neighbor's yard, but he never complained. Had he, I might have told him that dust is life, even if it makes us sneeze. Dust, it turns out, is Genesis. The story of the solar system and all that follows from meteorites and those who cherish them begins with dust. Stars died. They exploded. There were, researchers have conjectured, perhaps up to 10 supernovae whose traces we can read in the solar system today. When such stars explode, the remains gather together at far distance to start again as dust entrained with capes of gas. Supernovae occur when large stars, those about 25 times heftier than our sun, can no longer burn thermonuclear fuel. One ordinary second ends it all. The star collapses, sending shockwaves slamming through it, and the star just rips apart. Previously, the star had expelled carbon gas, which eventually condenses into diamonds. Countless trillions of diamonds, as scientist Harry McSween puts it, but not a single one will ever grace a pendant or seal a marriage vow. And some of these microdiamonds make their way into meteorites that land on Earth. Oxygen, plutonium, and iodine are forged in the hearts of dying stars. Gold, too, all that sent forth in a flash of iron demise. Stardust soared from explosions brighter than galaxies. Gas billowed. Shockwaves with their linty freight hit other particles and gases already lingering in one small pocket of the Milky Way. Gravity rescued them. About 4.6 billion years ago, this cloud of dust and gas began slowly to contract, rotate, and flatten. The heart of the presolar nebula began to quicken, and within a few thousand years, a protostar went through phases of contraction, expansion, and varied brightness. Eventually, after millions of years, this protostar would become our sun. Throughout the rest of this creation cloud, grains, flecks, and pebbles accreted into rocks. Eventually, these became planets, asteroids, and from them would come meteorites. So dust is, in fact, our ancestor. So that's a quick creation of the solar system done by a nonfiction writer. like to joke with my fiction writing colleagues, when they'll talk about, I don't know how many of you are taking, say, a fiction writing workshop, and you talk about point of view and omniscient point of view, and you sort of play God on the page in a way. It's like, well, nonfiction writers can do this too. I created the solar system in 4 paragraphs. So that's the creation of the solar system. And now I want to talk about the creation of the book, which I'm a little closer to. So I'm going to read just a little bit from the introduction to give you a sense of what the book is doing, especially in terms of weaving personal stories into the scientific stuff. Okay, I don't think there's anything I need to explain here. Okay. So this is from the introduction. Can you guys hear me okay in the back? Okay, good, all right. On any clear night, under a dark enough sky, we can see shooting stars. We wish upon them, even if we don't know quite what they are. Of course, they're not really stars, and even if we don't know where they come from or what they might tell us about the universe. It's as if we're eager to pin our chances on something strange and sudden, something beautiful beyond our ken. Across cultures and time, we have written ourselves into the sky. We create constellations, transforming the random spatter of stars into shapes and stories. We name planets after gods. And we associate meteors and meteorites, the light of dust or rocks burning passage through the air, and the stones that after such fire sometimes fall to earth, with the most elemental aspects of our lives: good luck, ill fortune, and even death. Meteorites are, in fact, implicated in the seeding of life's ingredients on Earth, and even the most indifferent know that these bits of former asteroids have rained devastation in the past and threaten to do so in the future. Meteorites are the alpha and omega of geology. These rocks, mere rocks, encompass the origins of life and the fact of death on our planet. Not surprisingly, we try to tame the wildness of meteorites by incorporating them into popular culture. Movies show humanity outgunning asteroids or comets headed for Earth, or at least surviving the effects of massive impacts. Accounts of actual space rocks whizzing by are now relegated to the inside pages of newspapers because it seems we've had too many close calls. Then again, and I wish I had the photo to show you, so you have to just imagine this. The front page of the July 5th, 2004 Weekly World News, it's like a tabloid you get at the grocery store, like the National Enquirer. The July 5th, 2004 Weekly World News announced, quote, "Another meteor fells Pope." Okay. Amazingly, the 900-pound stone did not kill him, though a photo shows the pontiff unhappily pinned under all that weight. An episode of Gilligan's Island called Meet the Meteor featured a meteorite that accelerated the aging of the hapless castaways, but they survived, and the professor even made a Geiger counter out of bamboo. In the otherwise forgettable movie My Super Ex-Girlfriend, Uma Thurman got her hottie superpowers from a meteorite. So humor dilutes threats, as does possession, literal or metaphoric. We can set meteorites on our mantles, displaying them as specimens, including some iron meteorites that have been ablated or melted into fantastic shapes, like Henry Moore sculptures, and sometimes just as pricey. An English breakfast cereal, Shreddies, once included little packets of meteorite dust as a promotional giveaway, and I've wondered how many kids sprinkled their new treats over cereal and milk. Grown-ups might be interested in knowing that a lingerie company sells stockings in a color dubbed meteorite gray. More poignantly, we christen asteroids to make them serve our needs. Astronomers have bestowed the names Solidarity, Magnanimity, and Compassion upon 3 asteroids as tributes to the victims of the September 11th attacks. Eros and Thanatos, indeed, Freud might have said. So meteors, shooting stars, flash across the sky all the time. Some of them contain rocks that are large enough to fall more or less intact onto the Earth's surface. This has been happening for billions of years. Covertly dark or blandly gray, often woefully misshapen, that's what many meteorites look like. Lumps, so ordinary seeming that most people would never notice these rocks have fallen on farm fields, deserts, shorelines, or backyards. The untrained eye can even mistake some meteorites for chunks of concrete, as if a cosmic road crew had jackhammered a solar highway and sent its congeries spilling down, briefly lit, to land among soybeans or ferns. Those who quest for meteorites, however, recognize them amidst the average rubble of the earth, the way a birder hears rare song untangling itself from a forest full of sound. Passion does that. It sharpens one's senses, it changes the world. Some people, myself among them, discount the notions of heavenly jurisdiction over a person's life, whether it's thinking your wish upon a falling star has come true or, say, believing in a horoscope. Yet I have found that in actual and often moving ways, the fallen sky can reveal secrets not only of the solar system, but of our hearts. That is why this is an intimate history of shooting stars. We go out hunting meteorites, and some of us find ourselves as well. Years ago, when I lived in eastern Kansas, I was trying to deepen my connection to the tallgrass prairie, to find stories that might enrich those austere horizons. Thumbing through a volume by the nature writer Edwin Teale, I came across the history of a homesteading farm wife who harvested not only wheat, but one of the rarest meteorites known to science. I was then also writing a book about extinct birds, and I couldn't yet fathom that the grief I felt for their fates was also in part an expression of many inarticulate griefs I carried in my life. Prompted by those inner darknesses and by the words of Teale and others, I went outside at night and looked up. I saw and learned the stars. I used them as a balm, and I saw meteors, sudden thin streaks on any given night, showers of them in the summer, watching with my wife as we camped beside a marsh and sand dunes in Colorado, and in our front yard, the one I'd walk away from, long after fireballs had exploded one November, golden shocks in the sky. All this led me to learn more about meteorites than I ever thought I could. And so this book has become also a chronicle of some of the most important meteorites we know of, stones that have altered our knowledge of the solar system and our place in it, and as such serves as a kind of informal record of scientific recognition over the past 200 years. I've especially tried to convey how individuals and cultures have valued meteorites, how they've been venerated as objects of power and continue to be objects of profit. But also, and this is crucial, how meteorites have become, through the rigors of science and the marvels of story, objective correlatives for our desire to live both with mystery and explanation. So whether someone wishes to possess a meteorite, to pass around at an audience, to sell it, to crack it open in a lab for discovery, the meteorite must first be found or hunted, which often means you have to be willing to go where the meteorites are, instead of waiting for them to show up in the mail. So I traveled to meteorite sites around the world, from the nearby to the far-flung, from a small-town street corner in Kansas to the iceberg-clouded coast of northwest Greenland, from a stranger's driveway in Portland, Oregon, to a German church made of rock born in the fire of a meteorite impact. Such journeys have impressed on me that wonder, whether from discovering a geological rarity or tracking down a hidden history or finding a lover, is not as pristine a feeling as some would think. I've learned about the despair of Oregon's Ellis Hughes, who stole a 15-ton meteorite by himself, lost it, and lost his marriage. I've learned that one man had his heart explode after reading calculations that the meteorite he sought had vanished when it hit the atmosphere. I discovered the triumphs and tragedies of an obscure Kansas professor who changed the course of science. I found that mine was a journey into wonder and its costs. Along the way, I bore changes in my life and realized that I was hunting the lives of the meteorite hunters, not just the stones themselves. And I began to understand these strangers' lives better when I accepted my own. Quests, after all, can come at a very high price. This was never more clear than when I suffered a breakdown in a wind-racked tent in Antarctica. Outside, snow drifted about boxes of meteorites. So we'll put Antarctica back up there. And I gave away a bit the ending of the book. And I'll give you a little bit of Antarctica here in just a minute. And I want to leave time for questions, too. Questions about the science of these things or writing questions. I don't know how many of you have read a lot of nature writing people like Barry Lopez or Annie Dillard. But in writing this book, I was thinking very consciously of the tradition of environmental writing or nature writing and actually trying to kind of work against it. But let me jump into a little historical narrative. So that was a bit of the introduction to give you a sense of the book. And really almost literally in the middle of the book, I tell the story of that obscure Kansas professor who had a life-changing event. And this opening is a rendition of that. I'm just going to check to see if there's anything here I need to... I mentioned kites in the first paragraph, and those are birds. They're birds of prey. So there's Mississippi kites in Kansas. So those are the kites I'm talking about. The rest of this is pretty clear. So this idea that you could get meteorites relatively easily, right? Go out and hunt them in the desert, go to Antarctica. I mean, it's not easy to get there, but it's relatively easy to get there. You don't have to wait for the rock to fall to get it. This was a radical idea. I mean, I think today we take something like that for granted because of hunting for artifacts, fossil hunting, and so forth. But in the early 20th century, this had really never occurred to anyone until Harvey Ninegar. So it was as radical a thing for a scientist to believe as, say, in physics today, those who are arguing that the speed of light can actually vary. Okay, so for the field of geology, for this guy to come along and say, you know what, you can actually go out and find these things, was really exceptional and really crazy. Almost literally crazy in the case of Harvey Ninegar. So let me read to you about his life-changing event. Again, back in Kansas, where this whole thing started. In McPherson, Kansas, at the corner of Euclid and Maxwell, two friends stood talking in the evening air. Harvey Harlow Ninegar and Elmer Craik, professors at McPherson College, had just walked from a revival in the campus chapel, and the men had stopped in front of Craik's home. Friday, November 9, 1923, had been a warm day, though now at 9 p.m., the air promised a night of barely opened windows and unfurled blankets. The mercury had dropped below freezing twice already in November, and the 36-year-old Ninegar, a biologist, knew the seasons and their markers far better than most. The kites and vultures had gone, and during the day, light mellowed over the prairie. Pegasus would ride the sky near zenith, while Orion the hunter peaked above the horizon, endlessly pressing his quarry. An obscure Kansas naturalist, Harvey Ninegar knew that standing with a friend on a pleasant autumn night was a gift. He would have felt that. And though the Earth's orbits around its star would go on, and how could he begrudge any passing season, Harvey Ninegar had for weeks wondered what his future promised, wondered if he should do something new, if he should study something mysterious, a thing so remarkable and little known that few lay people, let alone scientists, gave the matter much thought. On a small-town street corner, two friends talked. Perhaps such moments are enough. Perhaps not. The warm reprieves always pass. And now this is Harvey's voice. Suddenly, a blazing stream of fire pierced the sky, lighting the landscape as though nature had pressed a giant electric switch. The blade of light vanished, leaving a darkness seeming thicker than before. One instant, a man is standing in the dark, and the next, he's riding a trail of light to the end of his days. I think of the German poet Rilke, who said, "One moment, your life is a stone in you, and the next, a star." For Harvey, stone and star would be one, for as the poet also said, it is impossible to untangle the threads. 3 months earlier, Harvey had been amazed by an article on meteorites in Scientific Monthly magazine. Quote, "I cannot remember ever reading anything that so completely captivated me," he said. He told his wife, Addie, "I found a new subject that I'm going to make a hobby of. I don't know how I'll do it, but I'm so interested in this new word." By the time of the November 9 fireball, this really bright meteor, He apparently had been visiting with Kansas school children about this new word, about meteorites. Harvey Ninegar remembered his first encounter with the word and the rocks differently in a self-published autobiography. Visiting Chicago's Field Museum with another participant at an ornithological conference, they stopped by the meteorite display. The two men weren't sure what to make of the claims that rocks came from beyond the planet. After all, Harvey remembered that all during my childhood, meteors were regarded in about the same light as ghosts and dragons. He no longer believed in those, but meteors might as well have been myth, for they were hardly the stuff to make a scientific career, especially for a man trained in biology. As a member of the Church of Brethren, Harvey would have been baptized out of doors. The Blade of Light on November 9, 1923, was his second outdoor blessing. The meteor presented all the usual effects, enough light and noise to suggest the apocalypse, which this time had not arrived. The football banquet at Lloyd's cafeteria could rest easy and finish dessert. But apparent calamity can force reconsiderations as surely as calamity itself. Elmer Craik could not speak. Harvey leaned over the sidewalk and marked where he stood. The fireball had shot toward the southwest and vanished in the distance, behind a pine at 1010 Euclid. In his autobiography, Harvey wrote that he told Elmer Craik he was going to find the meteorite and that I was plotting its path from where I saw it. He laughed, but I was serious. Craik asked, "Has such a thing ever been done?" The answer was no. Others had searched for meteorites after they'd been seen to fall or had left craters, but no one had tried to chase fireballs. No one had scoured the landscape to find a meteorite where none had been discovered before. It was lunacy. The idea, the light, this new word, would lead Harvey Ninegar to quit his professorship, take a low-paying position at a regional museum, and from time to time deliver truck chassis in order to lecture about meteorites at college campuses, thus becoming, during the Depression, the world's most enthusiastic full-time collector, popularizer, and researcher of meteorites. Given this future of scientific enterprise and blue-collar labor, perhaps it's appropriate that the streets he stood on, Euclid and Maxwell, do not in fact directly memorialize the Greek geometer and the Scottish physicist as I had hoped. Rather, the former is named for an Ohio town and the latter for a local settler. My desire for a perfect beginning to Harvey's new ambition disappeared after some research, but the names honor pioneering, which is something he understood well. Before this unassuming man went after the fallen sky, no one believed that systematic searches and public education could yield hordes of meteorites or help us understand how these stones pelt our planet. Then came Harvey Ninegar, rational romantic, scientific entrepreneur, a small professor bent over a sidewalk beside streets named for the obscure. So that's the beginning of Harvey's story. I wouldn't be writing about him if he hadn't succeeded, right? So he goes on. He doesn't find any rocks from that fireball. And keep in mind, he's teaching at the time, has a wife and two kids, another one on the way soon. And he's driving around Kansas and he's trying to find this meteorite. He actually took out ads in newspapers in Oklahoma, Kansas, maybe even Nebraska, asking people to write to him to tell them where they were standing when they saw this thing fall. And again, now we might just think, well, that makes sense. You just get enough reports, you can triangulate, right? You can figure out where this thing would have fallen approximately, and you get this ellipse on a map, and you call it a strewn field, and the rocks may have fallen in there. But no one had done this. And he tells a very funny story about how he's at home one Saturday afternoon. He has all these letters, which I had the privilege of looking at Harvey's papers at Arizona State University, and the letters were fabulous. I mean, some of them were just completely, useless. Like one person mentioned the strange gas that had passed when the meteor had flown over him. That the only report of a strange gas from that meteor. But then there were reports that were really precise. Like, I was standing by this cottonwood, and I saw the fireball at a 35-degree angle, and it started, at this landmark, and it went to this landmark. And that's what he needed, because they present an optical illusion, usually, right? Like, I had several people call me and say, I saw that fireball over Salt Lake City, and I'm sure it just landed right over there. Can you help me find it? And I had to say, the chances that it landed just over there are really, really small. Okay, so he gathered all these reports, and he's with a physics professor from McPherson College, who after about the fourth letter just gives up and says, this isn't doing science. I can't do this. But Harvey persisted. He looks for these things. He finds two meteorites, not from this particular fireball, but people had them, had just found them. And he realizes even more emphatically, I can do this. Okay. The problem is it takes him about 6 years to actually find the first meteorite in the field, and it's a desperate move. If you can just imagine, here's this man, he's having a kind of midlife crisis, as I'm indicating in this section. He's feeling trapped in this small town in Kansas. He has gone on cross-country trips a couple times with his family. Much to the disapproval of the college and his neighbors. He's taken students on like a 30,000-mile trek around the country. This guy has lived a pretty interesting life. Now he's back in McPherson, Kansas, which is a very small town. He's at a small college. He's trying to make a name for himself scientifically, and he has this idea. And it takes him 6 years to prove that he's right. And it takes him this incredible risk of driving from Kansas to Mexico City right after the revolution in Mexico. And no one had done that before. And so he gets to Mexico and he finds meteorites in the field. But it's a really risky venture. Then he quits his job. So this is a guy who dreamed big and he made it, but not without some heartbreak. He goes on to become a collector and researcher of meteorites. He, I think, has something like 5,000 meteorites in his collection. He goes back to the Smithsonian. The geologist there had said, young man, if we gave you all the resources you want, you would be lucky to find one meteorite in your life. He goes on and he finds 5,000. So he really transforms this field. But there's a lot of pain along the way. In 1948, he suffers a nervous breakdown. 1948 was a bad year. He lost exploration rights at Meteor Crater, the crater in Arizona. He lost a huge and really rare meteorite to his rival, Lincoln La Paz, at the University of New Mexico. And there are scenes in the book. La Paz didn't leave his papers behind, so I had to rely on Harvey's, of the two of them, sort of toe-to-toe over this rock in the ground while the farmers in northern Kansas and Nebraska are just looking at these two guys like, are you crazy? So it was an interesting and rough life in some ways for Harvey. So I had the privilege of hunting meteorites myself, and I want very briefly just to share with you about a page to give you a little bit of a flavor of my experience in Antarctica, which was a long time ago now, 2003, 2004. Every year, the National Science Foundation, and for a time NASA, has funded an expedition to go to Antarctica to collect meteorites. And the team members change every year, although some of them are brought back as sort of like veterans, as it were, to help newbies like myself. And so I was there for 5 weeks, living in tent in Antarctica on the polar plateau, hunting for meteorites. I'm taking the picture here, but that gives you a little bit of a sense of the landscape. The first place I hunted meteorites was with another team, same expedition, 2 different teams, and that's what I'm going to read here in a second. No mountains there, and I had just moved with my partner Kathy to Utah. We'd been here for about a year and a half when I went to Antarctica. When I switched out and went to this team where there were mountains, it's like, oh, it's good. Mountains are back. So let me just read to you a little bit of what that was like. And I should tell you that the meteorites that are collected by these research teams belong to the scientific community. So we didn't take any specimens. That's why I had to order one from a meteorite dealer and get it in the mail. And so if you're a researcher and you want to study meteorites, you have something like 30,000 of these Antarctic meteorites that you can request for study. So they really are a public resource. So I'm at the La Paz ice fields, ironically named for the rival of Harvey Nininger, who caused his nervous breakdown. So I'm at this place in Antarctica called the La Paz ice fields. I mentioned ANSMET. That's the expedition. It's the Antarctic Search for Meteorite, ANSMET. When I mentioned Ralph, he's the expedition leader and a huge Simpsons fan, as it turned out, which was great for me. And I mentioned a couple of other names, a couple of other scientists, Andrew, and I think maybe one more. So those are just folks on the expedition. So let me just quickly read about a page, what it's like to be in Antarctica hunting for meteorites, of all things. At the La Paz ice fields, we're camped on hard snow, snow that's pocked or flat or broken like flakes near dimpled blue ice. And this is an example of that ice. This is where the meteorites would be found. We're surrounded by an Antarctic prairie that in one direction gives way to low rolls and swells that remind me of the Smoky Hills of Kansas. The wind-shaped snow extends to the horizon, sastrugi, those hard-packed furrows that metaphor can make into hundreds of shapes. Inches or feet high, the sastrugi become fishhooks and mesas, plowshares and ridges, catchy fins and talons. Some sastrugi have the aspect of tears. Where snow gives out, blue ice begins, not smooth but scalloped like a mold of mammatus clouds. The ice itself is the color of blue eyes with cataracts. Compacted snow inside the ice and crevasses filled with snow on the surface cross this blue like a cubist rendering of crazed kelp. The low hills not far from camp are the only relief on the horizon. A low hummocky ridge topped with nubbles of ice at regular intervals. Pinnacles, they're called. They're the round ice peaks, Barb tells me, of the below-surface topography that slows the flow of ice here, sort of like the exposed tip of an iceberg. But again, it's time for work. We unload the plane using a snowmobile to pull a sled piled with boxes of food, emergency supplies, and isopods. The latter are white metal bins in which we'll store the bagged and tagged meteorites for transport out of the field when the searches are over. The isopods hold my attention. They were used during the Apollo missions to carry lunar rocks here on Earth. Ralph will tell me later that he doesn't know if ANSMET's isopods were spares or if they may have held for a time samples of the moon. I like to think that they did. A stiff wind slows us down, and I have no idea how cold it is, cold enough that when I stop lifting, my sweat chills fast. We haul over more tents, food, sleep kits, and the survival bags of snacks and extra gear that we'll carry on the snowmobiles. I'll skip this little passage. We got started on our searches. We drive these things across the ice in traverse lines, waving at each other, trying to indicate where to space out and to group up. So we're sort of crossing the ice on these snowmobiles. And we're searching in places that we keep straight with fictional subdivision names like Cozy Katabatic Cove and Terrapin Landing Royale. Then I see a meteorite. No, I see two. After nearly 4 days at La Paz and a handful of weather-delimited traverses, I see two black chunks cut in the middle by snow. No mistaking it. Revving the snowmobile, standing, I squint and hope and yell and speed to the spot, my words lost in the din of the engine and the clattery smacks of snowmobile skis on uneven ice. The stone, the size of a small gourd put out as a countertop decoration in the fall, sits behind a bit of snow that made it appear to be two rocks. When I get off the snowmobile, I squat and peer at the meteorite, and I am disbelieving, and I am thrilled. Then I stand up, waving briskly, people arriving. I forget about the persistent pain of throttle thumb in my right hand and absurdly gloved smack the cargo box, and I exclaim a word that I won't share with you here. I was very excited. Is this your first? Andrew says. I respond with an enthused, oh yeah. I believe I had found what I had been looking for, a meteorite in the wild. And later that day, in the evening, beside the steady whoosh of our stoves, which kept the tents warm, Ralph busy reviewing field notes and photographs, I recall the conversation we had when we talked about the sense of connection and dislocation one feels when traveling across the ice prairies of Antarctica. Ralph had stunned me. You see what's in your heart, he said, not just what's around you. On some traverses today, the sunlight just right, I could see my eyes reflected on the inside of my goggles. I stared at myself, staring at the sterile sublime of Antarctica. Thank you very much.